All right, in this video, we're going to cover matrix multiplication and the use of the Greek notation summation sign to represent matrix multiplication. So let's start with our set notation. We have a set I, which are our index set, and say this is 3 elements, and say this represents set of origins. And then we have another index set, which has 2 elements, 1 and 2, and that this represents destinations. Again, if we want to refer to an element in set I, we'll use the lowercase letter I. And then if we want to refer to an element in set J, we'll use the lowercase j. Now we have 2 matrices. Say we have matrix C, and this is sort of similar to what you would call a table in Excel. Okay, this is, the rows will be I, the columns would be J, so it will have 3 rows and 2 columns. And C matrix, let's say, represents this matrix, say represents per unit shipment cost between the 3 origins and the 2 destinations. So it will have 6 elements, right? 2 times 3, 6 elements. So the from first origin to first destination, 1, 1, the cost is $2 per unit. From the first origin to the second destination, the cost is $6. Moving on, from the second origin to the first destination, $3. From the second origin to the second destination, $5. And moving on to the third origin, first destination cost is $9, and the final one is $4 per unit. Now let's also look at our other matrix, the amount shipped between these 3 origins and 2 destinations. Again, so from the first origin to the first destination, say we have shipped 5 units. And then to the second destination, let's say we shipped 10 units. Then moving on to the second row, second origin, we have shipped 20 units to first destination and 8 units to the second destination. Moving on to the third origin, we have shipped 12 to the first destination, and to the second destination, 30 units. Again, these 1, 2, 3s are, remember, belong to set I, right? Indexed by I. So I takes values of 1, 2, 3, and this 1 and 2 are the destinations that set J indexed by J. And again, this is a matrix, and it shows amount shipped between origins and destinations. So now we're going to do matrix multiplication. So what we're going to do is we're going to take say, the first element in the cost matrix multiplied with the first element in the amount shipped, right? So that's C11 and X11, okay? Because it costs $2 per unit to ship from the first origin to the first destination, and the amount we shipped is exactly 5 units between first origin and first destination. I'm gonna write down $2 per unit times 5 units. So this is just, again, as a reminder, this is $2 per unit, and that's 5 units. Plus, moving on to say, sticking with the first row still, okay? So let's stick with the first row, moving on to the second destination. I'm going to multiply these two elements. So $6 per unit multiplied with 10 units. Now we're going to move on to our second origin. Okay. So the cost to ship is now $3. And we are shipping 20 units between those origin destination pairs. So $3 per unit times 20 units. Okay. And continuing with that row, second row, we have a $5 per unit multiplied with 8 units. Again, these are the numbers I'm referring to, 5 and 8. Now I'm going to move to the third row, the third origin. So I'm going to multiply 9 with 12. Right, that's $9 per unit. And we shipped 12 units. Plus, I'm going to ship 30 units at $4 a piece. So $4 per unit times 30 units. So what did we calculate? We've been talking about this all along in this course, right? Transportation cost is effectively the total cost of shipment. Now we only have 3 origins and 2 destinations. So we have to add up the product of six numbers, right? So 1, 2, 3, 4, 5, 6. We added up 6 products. That's not bad, but imagine if you have in a question 5 origins and 8 destinations. It's no fun to write, multiply 40 pairs of data and then add them up. I'm personally too lazy for that. I want to use the summation notation and just be done with it. So how are we going to do it? How are we going to do this? So let's go back and remind ourselves what that 2, I'm going to switch to red. So remember this 2 here was C11, right? And this 5 was C11. The 6 was C first origin, but now moving on to the second destination. And this 10 was first origin still, second destination. And we keep going. Effectively, remember the elements in this C matrix, we can refer to them as, we can index and refer to each element as Cij, I iterating between 1, 2, 3, and j iterating between 1 and 2. Okay. And this X matrix has elements, 6 elements, and we can refer to them X sub ij. And I and j, X holds the amount, I and j tells us between what pair of origin and destination is that amount, does that amount correspond to? So say this 20 units here, it's 20 units here. Okay, that's an amount, that's our X, but that's really between second origin and first destination, right? So the I and j tells us what origin and what destination we're talking about, because there are lots of amounts, 6 of them, but it's also important to know the origin and the destination, the element we're referring to. All right, so that's Cij is the elements of the cost matrix, and Xij are the elements of the amount shipped matrix. So what we did is we took each Cij, multiplied it with the corresponding amount of the same origin destination pair. And we did this how many times? Well, we did this for each origin, so 1 through 3, and then we did this for each destination, 1 through 2. So don't forget to indicate the range of values I and j take, and we're summing over, we're iterating over. Summation sign, it just says you're summing, but you need double summation sign to indicate that you're iterating over both I, right? And you're iterating over also j, okay? So here we have the destinations and we have the origins, okay? So we need to indicate both indices. Now, and of course, this was simply some product, I should say some, not some product of all elements in the given 2 matrices. And how did we do this in Excel? Simple. In Excel, we used the sum product function. And instead of arrays, what we've selected are actually 2 tables. We'll select the unit shipment cost table and we'll select the amount shipped table. And it effectively does exactly this, right? And we're going to see that in now Excel. Let's move on to Excel. And I'm going to stop sharing. And where's my Excel? It's not allowing me to share Excel for some reason. Right, I'm going to share in this case. I'm going to share my book. Oh, there it is. Okay, Excel is showing. All right, building the matrix multiplication. So what do we have? We have a cost table, or we can say table, or we can say, all right, so we have, this is between 3 origins, right? So these origins could be retailer 1, or no, origin destination. So say, let's just stick with the word origin 1, origin 2, origin 3. And then we have the destination 1, destination 2. Oh, that's it, 2 destinations. All right. Destination 1 cost was $2. To destination 2, $6, $3, $5. I'm just copying down from my notes, right? So this was the cost matrix or cost table, giving us exactly the unit cost between origins and destinations, ING. And then we had the shipment amounts. Just gonna copy the origin. I'm gonna copy the destination. Now the amounts shipped were 5, 10, 28, 12, 30. Okay, these are the amounts. So what we could do is we could just really do the long way, right? And we can just calculate Cij times Xij, which would be all right, which effectively would be, I'm going to take 2, multiply it with 5. And then I'm going to just copy the formula. So now you see 6 and 10 are multiplied. And then I'm going to copy this across the different rows. Let's click on one number. So here, 40, double click. You see 5 and 8 are multiplied. So this is just showing the cost. For example, the 6 is showing the cost between having shipped between origin 2 and destination 1. This is how much we spent. Our goal was to find the total cost. So we could then cost sum of all the individual products that we calculated. We simply select the whole table and voila, we get the total cost. But this is literally similar to multiplying every element one by one, right, in the 2 matrices and then adding them up. We know a more efficient way of doing all this. We don't need to create this table. All we needed was our cost table and our amount table. So using that, I'm just going to use sum product, which is just allowing us to do matrix multiplication. Select the cost table and that's it. We get the same number. So this is matrix multiplication and summation notation.